Now for the last example, let's finish up the one on the packet and evaluate at 4 pi over 3 for each of our 6 trigonometric functions. So sine of 4 pi over 3, sine is always y. So again, we could always want to know, well, where are we at and what is our point? So sine is y, so sine of 4 pi over 3 should be negative root 3 over 2. Cosine of 4 pi over 3, x, should be our first two fundamental points. And tangent is going to be the ratio between sine and cosine. Negative root 3 over 2 divided by negative 1/2. Another nice trick for simplifying these fractions that we get with trigonometric function evaluations is to cancel out the 2's. So notice that there's a common denominator between the fractions. Well, one trick that I could do is I could cancel out the 2's in both cases. And that it makes sense because I could just multiply top and bottom of that fraction by 2, which in both cases would nullify or cancel the 2 out. And additionally, a negative divided by negative is always a positive, another quick cancellation that I could do here. But this particular ratio, the tangent of 4 pi over 3, would end up being root 3 divided by 1, or positive root 3, because it's negative over negative. But anyways, simplify quite nicely. And again, we should always be simplifying our answers. Good habit to be in. Now for the 3 reciprocals, let's start with secant just randomly. Call that secant is reciprocal to cosine, aka flip the cosine. So again, I could just flip cosine. That's the easier way to do it in my opinion. Flipping cosine is negative 2 over 1, of course, is just negative 2. Cosecant is the flip of sine instead. So if I flip sine on over, I would get negative 2 over rad 3. And again, we would generally want to rationalize this. So multiplying by the denominator will help me rationalize the denominator, which would give me negative 2 root 3. And that will not simplify, unfortunately. And then the cotangent for the last of the bunch is going to be the reciprocal to tangent. So if I flip, it's even nicer to start with the simplified version, since I know tangent reduced to 3, cotangent will reduce to, well, it would just be 1 over rad 3. And I could rationalize that by multiplying by rad 3 on top and bottom, which would give me root 3 over 3. And anyways, these are very standard looking answers for the trigonometric functions evaluated at the various positions. Since in order to use the unit circle, we need to use these values. If we notice that the unit circle is filled with these weird fractions, really it's just, when we're evaluating, it's going to be some form of these sorts of roots as we're evaluating trigonometric functions at positions like pi, pi over 2, pi over 3, or whatever, any location we want to, assuming we know it on the unit circle. One other thing before we finish this one up is you can also use your calculator to check your answers. Now your calculator is not capable of answering using radicals. Well, some really advanced calculators are, but the TI-84, the one that we typically use in class, is not. So let me go ahead and pop that up. Just kind of show you how we could check it out on the calculator. But your calculator has the ability to evaluate trigonometric functions as well. So there's no reason we couldn't use this as a way of checking to make sure we're making sense of all this and we're not screwing anything up. So let's say with 4 pi over 3, let's check our answers. So let's say we were to do the sine of 4 pi over 3. We could start by hitting the sine function for pi is right there above the caret. You have to hit second caret to get that, divided by 3, close it up. And assuming my calculator is in radian mode, it should work. And this is another thing we're going to get into in the next, or maybe in a couple videos, is difference between radians and degree measurements. But you might want to check to make sure if you hit the mode in your calculator that it is currently set to radian mode. If it's not, it's going to give you a different answer, and we'll get to that. But basically, I'm good to go. And if I type in the sign of 4 pi over 3, it gives me uh, negative 0.866. So notice that the issue with the calculator is when we evaluated it by the unit circle, we got this very nice fractional exact answer, as opposed to this kind of ugly decimal answer. Now, of course, we could round that off to make it look a little nicer, but my point here is the calculator gives an approximation of the value. It does not give the exact answer. In order to find the exact answer, you cannot use the calculator, but we can check it out. But so how I could kind of confirm that I actually did get the right answer in the negative square root of 3 over 2 is I could just check to see, well, what is the value of that? Notice it's exactly the same thing. So what you could learn to recognize is that this root 3 over 2 is about 0.866, and that's how I can kind of make sense of that. Now, I could also do the cosine of 4 pi over 3 with my calculator. Notice that actually in this case, it does give me a nice exact answer. Because it's 1/2, and we all know that 1/2 is 0.5. And we could even change it to fraction to check, but cosine of 4 pi over 3 is indeed negative 1/2. And I could check the tangent of 4 pi over 3, well, which should be root 3. Now, root 3, you might recognize, is about 1.7. But one of the things is your calculator will not be able to convert it to the root. So like I said, in some cases your calculator will give an exact answer, but in the case when it is irrational, you're out of luck.